Welcome to the next video in the preparation class to get your amateur radio technician class license. That is video number 19 out of 21. In this short video, I'll discuss scientific notation. In previous videos, I've used the terms megahertz, kilohertz, milliwatts, picofarads, and more. In this session, I'll go into detail about what those prefixes, mega, kilo, milli, pico, nano, whatever, all actually mean, and how to convert from one to another. There are some 10 possible test questions on these terms. Essentially, this type of notation is used to substitute a prefix for zeros. Rather than saying 1,000 hertz, or cycles per second, the scientific community substitutes kilo for the final three zeros and calls this 1 kilohertz. The left side of the chart is pretty straightforward. Kilo to mega to giga, and each step removes three zeros, or moves the decimal point three places to the left. The right side of the chart seems to be more problematic for people. I've just memorized the sequence, milli, micro, nano, pico, in that each step adds three decimal positions or moves the decimal three positions to the right. So how many millivolts is 5 volts? I add three decimal positions and get 5,000. Going the other way, how many amps is 10 milliamps? I add three decimal positions, or move the decimal three positions to the left, and I get 0.010 amps. How many farads is 45 nanofarads? I add three decimal points for milli, three more for micro, and three more for nano, giving me 0.000000045 farads. Several of the test questions are on this slide. I'll go through my logic for each of them. Your method may vary as long as it gets to the right answer. To move from megahertz to gigahertz, I need to take away three positions or move the decimal point three positions to the left. So 2,425 megahertz is 2.425 gigahertz. To move from kilohertz to megahertz, I need to take away three positions, that is, move the decimal point three places to the left. So 28,400 kilohertz would be 28.400 megahertz. To move from milliwatts to watts, I need to add three decimal places. So 500 milliwatts would be 0.5 watts. To move from amps to milliamps means I need to move the decimal point three places to the right. So 1.5 amps would be 1,500 milliamps. To move from microvolts to volts means I need to add three decimal points for micro and three more for milli. So 1 microvolt would become 0.000001 volts, or 1/1,000,000th of a volt. And finally, to move from milliamps to amps means moving the decimal point three places to the left. So 3,000 milliamps would be 3.000 amps. I hope this helps a bit. The rest of the test questions about scientific notation are on this slide. Go ahead and stop the video and work through the answers. Have you worked out the answers? So here they are. 1 microvolt is 1/1,000,000th of a volt. You've already seen that one. 1,500,000 hertz equals 1.5 megahertz. But this is a bit of a tricky question. 1.5 megahertz is not one of the available answers, but 1,500 kilohertz is. So that would be the answer to the question. 3.525 megahertz would be 3,525 kilohertz. And 1 microfarad is equal to 1,000,000 picofarads. Scientific notation is all fine, but here's a change of pace, some random definitions. Relays are electrically controlled switches which use magnetism to switch the relay. Relays come in several flavors, including normally open. When the magnet is switched on, the relay closes until the magnet is switched off. Normally closed, which is the opposite of normally open. AB relays, connected to the A side until magnetized and then connected to the B side until the magnetism is removed. And then there are latching relays. When they switched, they stay in the switched position until switched again. Integrated circuits, or ICs, are everywhere in your radio and in your car and in just about everything in your house. These packages contain every component needed to perform the task, all the transistors, capacitors, resistors, coils, or whatever. I think of them as a kind of a magic black box. You put something in and you get something out, but who knows what happens inside. Perhaps that's why it's called magic smoke. Solder is the glue that joins electronic components to each other. There are three main types of solder: rosin core, acid core, and solid core. Acid core is primarily used in plumbing applications. Rosin core is used in electronic applications. Solid core can be used in either case with the appropriate application of either rosin or solder. Good solder connections are essential, and they look bright and shiny when the connection is made properly. Finally, you can spend several $100s on a good multimeter, capable of measuring volts, ohms, farads, henries, and much more. However, always check the settings before using. An excellent way to let the magic smoke out of an expensive multimeter is to measure something beyond its capacity, or even easier, measure volts in the resistance setting. This concludes session 19. We've covered scientific notation in some detail and then a few additional definitions. If you have any questions or concerns, bring them up in the next online session, or you can email them to me at rolandksmith@gmail.com. We'll see you online.